So here in third grade, we are very interested in developing what we call our math facts, especially what we call fluency with math facts, where we can get the answer to these questions relatively quickly and without too much extra thought. And so one way we want to do that is definitely not to memorize, but to see how these numbers are related to each other. What is the relationship, for example, between like a 7 and a 9? Like how can I play around with these numbers to make them a little bit easier to add? And so that's what we're going to do right now. So starting up with 7 plus 9, when I look at 7 plus 9, I really easily see very quickly that 9 is really close to 10, and I know if I just add one more here at 10, and 10 is such an easy number to add to, right? So it's what we call a friendly number. And so we like to think, hey, how can I get to a friendly number really easily? Maybe I can just take 1 from this 7. And so kids need some practice with that. So instead of saying 7 plus 9, I might break that 7 up into 6 and 1. And now I can say 1 plus 9 is really easy. That's 10. So it would be 6 plus 1 plus 9 is 10. A lot of kids know that pretty quick. So 6 plus 10 is 16. So now I go back. 7 plus 9 is 16. That's one way. It's just kind of changing. We say it like this, like how can I make this problem a little easier by making a small change to how I solve it? So we're just changing it just a little bit, being a little bit flexible with this to change it to make it an easier problem. So like this one for 8 plus 7, I'm thinking kind of the same thing. Like I know that 8 is pretty close to 10, so maybe I'll just take a couple from the 7. Right? I know, for example, 8 plus 2 is really easy, so and then 2 and 5. And so I'm thinking 8 plus 2 is 10, plus 5 more is 15. And again, it's because we often know 10 plus something is really easy. It's that base 10 makes it really easy for us to add things and get a total. So over here, 8 plus 7 is 15. Same down here with 8 plus 9. I'm kind of thinking again, kind of like 7 plus 9, that 9's really close to 10. But I'm also noticing that a lot of third graders especially know their doubles. And so one example of a double might be 8 plus 8. A lot of kids know that automatically, 8 plus 8. And so I know I can break this 9 up into 8 and 1, again, because kids often know their doubles. And so we kind of bring that over here, and I might say 8 plus 8 plus 1. A lot of the times kids will see that 8 plus 8 and they'll say automatically ooh, I know it's 16, and then I just need to add one more, so that's 17. So 8 plus 9 is 17. Same idea down here, but instead of doubling, we call these near doubles because they're not exactly doubles. In this case we doubled and we kind of added one more. In this case we might double and take away one, right? So we can say, well, 7's really close to 8. What if I still just do, 8 plus 8, right? I kind of pretend that this is an 8. So 8 plus 8, I know, like we just did it a second ago, 8 plus 8 is 16, but I know I added one too many, so I'll just take one away. All right, so again, 8 plus 8 is 16, and then I take one away, and I get 15. So 8 plus 7 is 15. Now this works for bigger numbers and smaller numbers too, but it's just kind of easy to work with some of these frequently missed addition problems, like 8 plus 7, 8 plus 9, and 8 plus 7, and 7 plus 9. But even right here, something like 3 plus 4. Again, a lot of kids know doubles. They know 3 plus 3 is 6, and then they say, oh, just one more, so that's 7. Here's just a quick example of how you might extend it with some larger numbers, like how it's applicable to other numbers. It's kind of the same idea here. I noticed that 29 is really close to 30, right? I want to kind of get it to 30 really quick. So I can still just break up that 7 into 6 and 1 and kind of give that 1 over to the 29. So now 1 plus 29 is 30, right? So now I have, sorry, I know it's getting all funky up here. I have 6 plus, and then again 1 plus 29 is 30. So 6 plus 30 is 36. I guess basically the same idea here, right? 28 is pretty close to 30, so I just kind of want to take 2 from the 7, and that leaves 5 over here. So now 28 plus 2 is 30, plus 5 more, super easy. with our base 10 system is 35. Instead of just counting on that, that is what we call a more efficient strategy. So instead of just saying 28, 29, 30, 31, 32, 33, 34, 35, we can get them thinking a little bit more efficiently and sophisticatedly by breaking it up into easy parts, like 28 plus 2 is super easy. Now this gets a little interesting when you get into still doing those like doubles and near doubles and things like that. But I gotta say, like 28 and 29, I noticed that they're like pretty close to each other, so I kind of want to double them automatically. I'm still going to break it up a little bit, but I'm going to break it up a little bit further. Like I might say this is 20, and this is 8, and I might say this is 20, and this is 9. But still, I'm kind of noticing, like, first off, doubles, double 20, that's awesome. And then I can kind of do that double 8 here thing here too again. It's like breaking this up into 8 and 1. So I mean, it's a little bit of keeping track of things, but it's like what we're trying to do is not have them memorize answers, but we're trying to have them understand like what's actually happening. So this is really cool because like right here I can just say, oh, 20 plus 20 is 40. That's easy. 8 plus 8, I know my doubles. 8 plus 8 is 16, right? So I can just say 16. And then just one more, right? So I did my double 8, and then I just have one more. So plus 16, plus one more. And this gets into 40 plus 16 is relatively easy to add. 40 plus 16 is 56, plus one more is 57. And you might say that this is a little bit tricky right here, and that's totally true. This might be a place where you'd break it up again. 10 and 6, 40 plus 10 is 50, plus 6 more is 56, plus one more is 57. Again, the idea, not that they need to memorize everything, but that they have like a strategy for kind of making things easier. Is this whole idea of like, how can I make it a little bit easier, and then solve it that way. Same idea down here with the like near doubles, but like this one would be the -1. And I noticed that like these even aren't doubles like the 30 and the 20, but I think base 10 that still get pretty easy, right? We know this is 30, and this is 8, this is 20, and this is 7. Right, 30 plus 20, relatively easy for third graders to add up. 30 plus 20 is 50. 8 plus 7, we know, like we're kind of sort of pretending like this is an 8. 8 plus 8 is 16. But we also know that we did one too many here, so we're going to subtract 1. Oops, not subtract 7. We're going to subtract just 1. So 50 plus 16 is, oh, what is that? 50 plus 16. See, I'm even going to do it in my own brain just to make sure. So that's 10 and 6. 50 plus 10 is 60, plus 6 more is 66, but I did one too many when I did this thing down here. So that is 65. I wanted to talk about 28 plus 29 one more time because in my head at least I think a lot about quarters are 25, so I actually wouldn't have necessarily done doubles here. I probably would have done something like this. 25, 25, and then I know this is 3 away, and I know this is 4 away, and a lot of people know that. Like third graders know that a lot of times too. Like they know their quarters. They know 25 plus 25 is 50, and then that leaves some pretty easy numbers for us to play with. 3 plus 4 is 7, so the total is 57. Again, really the point isn't that they have a specific strategy, but they know that they can be flexible with numbers, break them apart to make them easier, finding patterns that they understand, relationships that they understand. 25 plus 25 is where my brain went, so I just wanted to make sure I shared that too. So, good luck.